All right, so completing the square. It's not one of the three methods of solving a quadratic per se, but it is a method that comes into play in a couple different areas, completing the square. And it's really a means to an end. So why would you complete the square? You would complete the square so you can do something else. So there's thinking in relationship to quadratics, there's a couple ways that they apply. You can complete the square and end up with the special case for taking the square root of both sides. You know, sometimes that's a little bit more effort than it's worth, to be quite honest with you, and that's kind of the context right now that the author is introducing a difference of two squares. Later on down the road, we're going to graph quadratics. And when we graph quadratics, the graphing form for quadratics is the form you get when you complete the square. And that's really the better value. So in that relationship is where the value really comes in. And it doesn't only apply to parabolas, quadratics. It applies to graphing circles, which you'll do in advanced math, those of you that take it. Applies to graphing ellipses. It applies to graphing hyperbolas. And so it's really a thing where you're going to use it to get a function or an equation into the form that you want to use. So again, right now, what are we going to do with completing the square? We're going to use it so that then we can take the square root of both sides and solve a quadratic. So that's the first way. But down the road, the bigger value is putting quadratics into the proper form to graph them. So focus in, and I don't think it's a hard method, but it is something. There's a few things that you have to learn. All right, so what is it all about? It's a method that results in a perfect square. We're making a perfect square, which will allow us to solve some quadratic equations by taking the square root. And again, that's taking the square root of both sides. Okay, so what are we dealing with? We're dealing with quadratics where it's basically you got the quantity squared. You've got a middle term, right? You got an x to the first power term. So normally when we see that, we would say, oh, we can't take the square root of both sides because there's an x to the first power term. But actually, we can force it into the scenario where we can. Again, do I think this is the best method in solving just regular old quadratics? I don't think so. But the value does come later, and that's why we'll begin to teach it now, and then I'll refresh your memory on it later. All right, let me do it this way. Just try to focus your attention. Okay, so here's the original right here, and you can see that it's already in the form that's up above. You got your squared term out front, then you got your first power term. They're both on the left, and then the constant, the number with no variables, on the right-hand side. So this one's already in the form that we want. If it were not, you would put it into this form. So if it were not already looking like this, your variable's on the left and your number on the right, then you would just move things to get it in that form. Not a big deal. We can do that. And sometimes you'll have to factor out common factors out of the left-hand side. Well, right here we have an x squared and a 6x. And there are no common factors to factor out. But like always, you have to look. You got to look. You got to be aware. You got to be looking for common factors. This one doesn't have any, so that's good. So here's basically the concept. We have to make this parentheses right here be a perfect square. If we can get it to be a perfect square, then we can factor it, and that's what we want. So right now, it's not a perfect square. And you might say, let me pause here as well. You might say, well, wait a minute, I can factor out a common x. All right, you don't want to factor out the common variable. So I'm surprised nobody raised their hand and said, isn't there a common x in there? Which some of you thought that. Here's your problem. And look, I just got to keep telling you guys, I don't know what's up with this class, but in my 30 years of teaching, you are the worst. Without asking, you are the worst in 30 years of teaching. And that's probably averages 6 classes a year for 30 years. It's 180 classes. You are the worst. And some of you better get out of it because it's not good. It is not a good thing. And if you're reveling in it, then you're an idiot. I'm on the idiot thing lately. I don't know. Judge Judy. I don't know if you ever watched Judge Judy. She loves to call her plaintiffs idiots. All right. So I can do that because I'm not calling any of you in particular an idiot. Just nebulously out there, all right? So I have nobody in mind. Just, Okay, so anyhow, we don't want to factor out the common x. We need those x's to complete the square. But if there was a common factor of the numbers of the coefficients, that we would factor out. Okay, so let me clarify that, because I'm sure half of you are thinking, isn't there a common x? And so that's reality. All right, so we're set up right now to go ahead and complete the square. If you'll notice, I left room in my parentheses because we're going to stick something in there. We have to make this a perfect square. That's the point. We have to figure out what quantity should we put into that hole right there to make a perfect square. So there's a method to it. You divide the b value by 2 and then you square it. Okay, so again, if you look back up at the form, what is the b? The b is the coefficient of the variable to the first power. So obviously right here, our b is a 6. So what do? You take that 6. I'm going to do this off to the right. I think you should in your notes as well, so you can go back and look at it. I'm going to take the 6 and I'm going to divide it by 2. And then I'm going to square it. So 6 divided by 2 is 3, and 3 squared is 9, right? 6 divided by 2 is 3, and 3 squared is 9. And so right now, I'm going to add a positive 9 right there. Now here's the thing. If you just add a 9 in there, did we not just change the value of this whole equation? Yeah, we did. We just stuck 9 in there. So how in the world are we going to make it work if we just stick a 9 in there? So what are you going to do? You gotta compensate. How are you going to compensate for that 9? I need an idea. Luke? Yeah, we're simply going to take that and add the same amount to the other side. And I think that's probably what the blue part says here. I'll do that in blue. So we stuck 9 in there. You got to add the same amount to the other side. Yes, Leah. How did I get from 3 to 7? I have no idea. First addition notes, that's how. So that is a 3. Only the shadow knows, and that's the green hornet. All right, so now we're at 3 plus 9. So that's what we were after. If you look now, it's just factor the parentheses, and this is a perfect square. All right, so watch how this goes. This is always a perfect square. That was our point. So how do you figure out what goes inside? Take the first term and do its square root. So the square root of x squared is x. Do the sign of the middle term. No matter what the sign of the middle term is, put its sign there. In this case, it's a plus. If that would have been a minus, we would have put a minus. Sign of the middle. And then the way you finish it up is take the square root of the last term and put it last. However, don't forget, this is now a perfect square, and so it's that quantity squared. If you were to multiply x plus 3 times x plus 3, you get x squared plus 6x plus 9, right? That's the whole point. So this was a perfect square trinomial. All right, so let me just pause 1 second. Let's just leave your notes the way they are. So what if instead I went to factor this with 2 trinomials, or 2 binomials? Again, don't do this. You know, what would you do? You do x and x. You're looking at 9. You're going to do 9 and 1 or 3 and 3. And you say, oh, 3 and 3 works, right? Because, again, my middle term is going to be 3x and 3x. Yes, that's a 6x. And that is the factoring of that. And what do I get? An x plus 3 quantity square. Okay? So, again, but we know it's a perfect square. So we can do the shortcut. How do you factor a perfect square by the shortcut? Square root of the first, sign of the middle, square root of the last. Just remember to square the quantity. And on the right, we got a 12, right? Okay, so this chapter, if we are now going to solve this by taking the square root of both sides, we got to continue on. So we're done with completing the square. So all of that was completing the square. And now if we were to finish solving this thing, and I'm gonna rewrite it below just for clarity's sake. So now we're ready to take square root of both sides, right? So I'm going to take square root of the left. I'm going to take square root of the right. And x plus 3 is the left, because square roots undo squares. And can you simplify? Somebody tell me, what do we end up on the right-hand side when you simplify that root? Abigail? All right, so we got plus or minus 2 times the square root of 3. And if we're going to finish this thing off, we got to isolate the variable. So we're going to add a negative 3 to both sides. Again, proper form is to put this negative 3 in front of the radical. So we end up with negative 3 plus or minus 2 times the square root of 3. Negative 3 plus or minus 2 times the square root of 3. Again, that's two answers, right? It's just written together. It's negative 3 plus 2 times the square root of 3. The second root is negative 3 minus 2 times the square root of 3. That's an exact answer. We're going to leave it. That's just the way we want it. That's good. When we solve using the quadratic equation tomorrow, we'll see similar type results that look like that. Okay, so that's the idea. So let's see if we can reproduce it. Got to get rid of my shade so I can move this up. Okay, so this one, you look at it and it's set equal to 0. So normally, again, you wouldn't say, hey, I'm going to solve this by taking the square root of both sides. But again, you can if you go ahead and complete the square. So in this situation, you got to move your 7 to the other side, right? So add a negative 7 to both sides. Notice I left some room after the x to the first power term, right? Because next is to group your variable terms. Look to see if there are any common coefficients to factor out. There are not. All right. And so go ahead and see now if you can continue from there. Just get it to where you complete the square and then stop. Just complete the square and stop, and then we'll finish it together. Doesn't really matter, right? Doesn't matter if it's positive 8 or negative 8, because once you square, it's going to be positive anyhow. So 8 divided by 2 is 4. 4 squared is 16. Add a 16 in the left, and therefore add a 16 to the right. And you should have gotten x minus 4 quantity squared equals 9. How many got that? Okay. And if you didn't, just take note of what goofed you up there, what messed you up. Okay, so again, we need to finish, right? Any questions so far on that part? Okay, so to finish, we're just going to take the square root of both sides. Because again, completing the square was a means to an end. Go ahead and finish it. Finish it from there. All right, so hopefully you took the square root of both sides. You didn't forget the plus minus. You did the square root of 9. And then, remember, we can split that one up, right? So one time do the plus 3, move the negative 4 to the other side. The other time, do the minus 3, move the negative 4 to the other side. That one would have factored. You could have actually solved this whole thing in the beginning by factoring. But again, I'm trying to show you the method on some easier ones right now so we can do the harder ones. Any questions on that? Anybody? Anyway, anyhow. All right. Okay, so if you look at 4, how are we going to start this thing off? Somebody raise your hand and tell me how to start this thing. Jeff? All right, so what do you want to factor out? Yeah, you want to take out a negative 3. The other thing that's really going to help in these is if you have your squared term as positive in the front. And so what is this then? A negative 4x. So I factored out the negative 3 out of the negative 3x squared minus 12x. Okay, so somebody tell me what to do next. What's next? What's next? Luke? It is a positive 4x. Whoa. Fat guy. Yes. All right, taking a negative 3 out of the negative 3 and a negative 3 out of the negative 12. If your brain doesn't work real well with those, you could divide both terms by negative 3. But again, to do this, this would be like a negative 3 times a 4, right? Take the negative 3 out, that leaves the positive 4. All right, what's next? Josh, what's next? All right, so I'm going to divide the 4 by 2 and square it. So that one's kind of boring. 4 divided by 2 is 2. 2 squared is 4. And hopefully everybody agrees I put a positive 4 right there, right? Okay, so now I need everybody to think about what goes on the other side. And probably over half of you are going to get it wrong. Which if you have half of a brain, you should say, why are half of us going to get this wrong? There must be something different. So let me not be half of the ones that get it wrong. All right, so what goes on the other side? I'll give you a second to think about it. What goes on the other side? What goes on the other side? All right, so on 3, out loud, tell me what to put on the other side, all right? Like you're going to say 57,000, all right? Something like that. Right? On 3, here we go, 1, 2, 3. Okay, so a lot of you took my admonition, and I heard a lot of negative 12s, right? How many said negative 12? Because I heard a bunch of them, okay? About half of you. If you don't know where that negative 12 came from, when we put a positive 4 into that spot, remember, it has a multiplier out front. So in reality, putting a positive 4 there is like putting a negative 12 on the left. Does that make sense looking at it? Right? Because you got this negative 3 times that positive 4. That's a negative 12. So in actuality, we put a negative 12 on the left. We have to then put a negative 12 on the right to have the thing balance. In reality, what did we actually put into the left? A negative 12. Because that negative 3 is a multiplier of it. Therefore, we got to put a negative 12 on the other side. Okay, now we can go ahead and complete the square. Don't forget the negative 3. It's still there. Square root of the front goes in the front. Sine of the middle. Square root of the back. And don't forget to square the quantity. And right now, this is equaling 8. Okay, we have finished completing the square. Now we still need to solve this thing by taking the square root of both sides. So first thing I would do is move the negative 3. Agreed? And for clarity's sake, I'm just going to rewrite this step. Let me stick my negative in the top. And hopefully you agree at this point, ready to take the square root of both sides. So I got a couple things here trying to refresh your memories. So the left is no sweat. That's an x plus 2. Remember, any fractional radicand is the root of the numerator divided by the root of the denominator, right? So somebody simplify. So it's going to be, oh, let's see. I better not skip a step. So let's just do it this way for a moment. Let's do plus or minus the square root of 8 over the square root of 3, right? Hopefully you agree with that. We can split it up. And before we go any further, we need to simplify. So what's What does the square root of negative 8 simplify into? Somebody give me the answer to that. Square root of negative 8, Destiny. Close. She said 2 times the square root of 2. Close. Abigail? Yeah, so that's a plus or minus 2I times the square root of 2. Don't forget, right, for the negative 1? Agreed. And on the bottom, we still have this square root of 3. And can we leave a square root of 3 on the bottom? So what's the name of the method for getting that square root of 3 off the bottom? Just say it if you know it. Rationalize the denominator, right? So we got to multiply the bottom by a square root of 3. And whatever we do to the bottom, do the same thing to the top. All right, I'm going to move to the right because I'm running out of room below. So now we're at x plus 2 equals plus or minus 2I times the square root of 6, right? Square root of 2 times square root of 3 is square root of 6, all over a 3. Yippee. What fun. This is awesome. And are we done? Is the variable isolated? So the last thing we got to do is move this positive 2, right? So we're just going to add a negative 2 to the other side. Where does it go? It goes in front of this plus or minus. And if you were going to write this technically, you would rearrange it a little, but I'm just going to leave it. Plus or minus 2I times the square root of 6 over 3. And that's both solutions. And those are exact answers. So really you have negative 2 plus 2I times square root of 6 over 3, and negative 2 minus 2I times square root of 6 over 3. Hunter?
Is the negative 2 off to the side, or is it on top with 2I?
It's really its own, it's the real part. So if you go back to imaginary numbers, it's the real part, so it's a number out in front of now this whole fraction. So it'd be on the par of something like this. Negative 2, let's just use minus 7/5. I mean, that's the kind of thing it would be. It's a whole number out in front of a fraction that is added to it. I don't know if that directly answered your question or not, but again, it's the real part of an imaginary, and technically all of this is the b, right? It's really a 2 times the square root of 6 over 3i. And that's not the best form, but we'll deal with that a little bit later on. Here, you know what? Might as well do it right now, because this course does things in a little bit different order than we did. In the last course, we used to have a whole chapter on imaginary numbers, and this one, it mixes them in, so I better put it in the best form right now. So again, you would do the 2 times the square root of 6 over the 3, and then your I would come in the back of the fraction bar. And that's the best way to leave that as a final answer, because you have your real part and then your imaginary part. So what was the big deal in this one? The big deal was, all right, I had to factor out a negative 3, but not only that, I had to remember that, or I had to realize by putting a positive 4 in, I really put a negative 12 on the left, therefore a negative 12 on the right. Okay, that leaves us then this one that I cannot get to now because something's holding me up. All right, good. So let's do one more. 2 more. All right, number 4, same kind of scenario. Only when you look at this one, we look at this and we say, oh, there's really no common factors, right? But here's the problem. I really need this x squared to be an x squared. If not, I'm going to have radicals and stuff in my perfect square. And so, believe it or not, I need to factor out this 2. I have to. Okay, so something new again, but that's okay. We can handle that. The front term is no problem. It's a x squared. So what you have to be careful here is, what does the middle term become? How do you factor out a 2 out of a negative 5? All right, well, hold on a second. And how many have an idea how to factor out a 2 out of a negative 5? Okay, so just pause. Let's go off here to the right. Let's suppose we had something like this. 2x minus, let's do 2x squared minus 8. We'll just leave it at that. And let's suppose you were factoring that and agreed you would factor out a common 2, right? And you would get that, right? Would not that get you there as well? If you divided the front term by the amount you factored out and the back term by the amount you factored out, doesn't that give you the x squared and the minus 4? You know, and you can do this, you know, if you had a 3x squared minus 12, if I want to factor out this 3, okay, I know this is x squared minus 4, but again, I can get that, and really, technically, you're doing this. Doesn't that give me x squared minus 4 if I divide both terms by 3? Okay, so with that information, can you then factor what we have here? We got to get that 2 out. Come on, go away. Forget it. We got to get that 2 out. So therefore, the front term is going to be x squared. What is the next term going to be? How many think they know now? Just a few more? All right, let me try one more time. All right, one more time. If I had 10n minus 30, technically this is factoring. Watch. I'm really multiplying it by a 10 over 10, the common 10. I leave the top 10 right where it is, and I distribute the bottom 10. So now I end up with the 10. What's 10n divided by 10? N. What's a negative 30 divided by a 10? A negative 3. And didn't I factor out the common 10? Okay. So, if we don't get it this time, we're going on. But now I just took out a common 2. So, what is left? Say it if you know it. Negative 5 halves. You might not like fractions, but that is what's left. Okay. Divide the x squared, the 2x squared by 2, divide the negative 5x by 2. All right, so that's how you do that. We're kind of forcing it, but it does work. Okay, now you got to do your b value, right? You got to divide it by 2, and you got to square it. How about if we do it that way? Do you like that? Divide it by 2 better? And can you invert and multiply? So just to be clear, before I square it, this is going to be a 5/4. Do you agree? Right? Invert the second fraction, right? And multiply. A 5 halves divide, here, elementary way. 5 halves divided by 2 over 1. Invert the second and multiply. Okay, so now let's square it. 25/16. Ooh, awesome. We're putting in a positive 25/16. What did we really add, though? Just multiply it by 2. What's 2 times 25 over 16? No, how about reduce? What's it 2 times 25 over 16? 2, 16. 2, 16. 25 over 8. Beautiful. And so that was a positive 25 over 8 on that side, and we need a positive 25 over 8 on that side. Beautiful. Oh, we are so fractionally challenged. Come on, they're not hard. They're not. All right, let's complete the square. Don't forget the 2 out front. Square root of the first, sign of the middle. Oh no, I have no idea what the square root of 25 over 16 is. I just have no idea what the square root of 25 over 16 is. Right? I mean, didn't we square the 5 over 4 to get 25 over 16? The square root is right back to what you had. All right. Anyhow. Oh no, now we have a negative 4 and a positive 25 over 8. Death of death. How about like a common denominator of 8? So how about negative 32 plus 25 for a grand old negative 7 over 8? Yippee! Isn't this fun? Math is so much fun. Look, you have to pay for puzzles. You get them for free. Well, not for free, but... Move the 2. Oh, no. How do I move the 2? I already have a fraction. Oh, my. Look. You can do the same thing again, or you can go back to way back in the beginning and multiply by the reciprocal and clearly see that that 2's in the bottom, right? So where are we at? X minus 5 fourths, quantity squared, equals negative 7/16. Take the square root of both sides. X minus 5 fourths equals plus or minus square root of negative 7 is an I, correct? I times square root of 7. And the square root of 16 is 4. We got to finish it. So I ended up with plus or minus I times the square root of 7 over 4. Right-hand side. Let's add a positive 5 fourths to both sides. Put your plus or minus, your square root of 7 over 4, and then your I goes across from the fraction bar. Plus or equals 5 fourths plus or minus the square root of 7 over 4i. 2 answers, all written in one. It's a work of art. It is a work of art. Okay, one more time with the fraction just to finish this thing off. Complete the square and factor the resulting trinomial. So just one more time. Question, Josh? Go ahead. Yes. Not really. I mean, you can use, well, it's imaginary for one, so lots of luck with that. Your calculator's not really going to let you play around with imaginaries, so no. You just got to go back and check your own math and check your own procedure. You're going to have to go back through, make sure you had your signs correct, make sure you did your division correct, make sure you added the right amount. But you can't really take that value and put it back in. All right, last one, number 5. If you just had to complete the square in this thing, so again, what would be a 4/5 divided by 2 quantity squared? If you'll think of it like this, it's a little bit easier, right? It's the same as multiplying by half. Dividing by 2 is the same as multiplying by a half. So just to be clear, hopefully you agree then, this thing reduces to a 2/5 quantity squared. So hopefully you agree you're putting in a 4/25. Can you finish that now by completing the square? This isn't an equation, so all we're doing is completing the square on this. So what do you get now when you factor that trinomial? Just factor that. Last thing we'll do. All right, square root of the first, sine of the middle, square root of the last, right? So n minus 2/5 quantity squared when you factor. All right, that's all my time. You got your homework there. Be careful. Tonight is the time to get this figured out, because you know what? Tomorrow we're going on to the next thing. So again, you got to get it figured out tonight. Don't take a day off. You can't afford it in algebra. Get it figured out tonight. At least get to the point where you can ask questions tomorrow, and then we'll continue on.